Hello friends, welcome back to ChemONotes. We already started with spectroscopy series. Today is part 3 and we are going to see basic principles of UV visible spectroscopy. So before we start with the principles of UV visible spectroscopy, just like the channel, share the channel to your friends and do subscribe if you are not subscribed till yet. So let us start. So in today's spectroscopy series, we are going to study basic principles of spectroscopy, UV visible spectroscopy and chromophoric shift. So let us understand what is UV visible spectroscopy. So basically UV visible spectroscopy is an analytical technique and used to study how molecules absorb, how they are absorbing the ultraviolet light or radiations. Now this radiations which you are going to see, ultraviolet radiations are having the range of 200 to 400 nanometers and visible radiations you can find it in between 400 to 800 nanometer of electromagnetic spectrum. Now it is based on the principle that electrons in the molecule can absorb energy and get promoted from lower energy level to higher energy level as shown in the diagram. Suppose this is the electron and if this electron absorbs the energy, now this what is going to happen when the energy is absorbed by the electron, it is going to promote from lower energy level. Suppose the energy level is E1, it will get promoted to next energy level, that is higher energy level, that is E2. Okay, so this is how on this principle your UV visible spectroscopy is based. So let us understand the principle of UV visible spectroscopy. The molecule contains electrons in different molecular orbitals, that we know that electrons are placed in different molecular orbitals. When light of a particular wavelength falls on the molecule, if the photon energy matches the energy difference between the two electronic state, so if there is a photon and its energy matches this energy difference, that is delta E of electronic state, the molecule absorbs that light. This leads to electronic transitions. Okay, so if there is energy which is going to match with the difference between the two electronic state, then this will lead to what? Transition, electronic transition. So what is the electronic transition? We can see that from sigma to sigma star the electron can move, that is higher energy, short wavelength, usually for in far UV. Then non-orbital electrons to sigma star, that is anti-bonding orbitals, the electrons can move. Similarly, the transition can become from pi orbital to pi star, that is anti-bonding molecular orbital, and your n to pi star. So important in visible and UV region. So from n to pi star. Now let us see this in a diagram, in a diagrammatic way. So these are the various kinds of electronic transitions which can happen when the electrons or the energy is absorbed by the electrons and if the electronic transition is taking place. Now for electronic transition which requires the highest energy are sigma to sigma star. So the highest energy, you can see here there are different energy levels. Okay, these are different energy levels. The electron can be in the bonding orbital, it can be in the pi bonding orbital, then in n non-bonding orbitals, anti-bonding orbitals, and anti-bonding sigma star orbitals. So the electrons can be anywhere placed in this. Now if the transition is taking place from non-bonding orbital to anti-bonding orbital, that is from n to pi star. Okay, So this shows the least energy which is required. Very small energy is required for n to pi star. Similarly, from pi to pi star, the electron can have transition. Then the electron can have transition from non-bonding orbital to anti-bonding sigma star. Then it can have from pi, that is bonding, to sigma star. Similarly, it can have from bonding sigma bond to pi star, that is anti-bonding, and sigma to sigma star. Okay, so these are different transition, electronic transition, which can take place. Now the highest energy is, you can see it is sigma to sigma star for electronic transition, while the transition requires the least energy is which one? This one's n to pi star. Okay, the energy order of different types of electronic transition is as under. So whatever is the distance or the energy required, so in the same order it is given. Sigma to sigma star, if you can see the height of the transition, it is highest. Okay, so sigma to sigma star is having more energy, requiring more energy. Then it is sigma to pi star, then pi to sigma star, then it is n to sigma star, and pi to pi star, and so on. So as you go towards the right hand side, the energy order is higher. Okay, as you go to the right hand side, that is this side, the energy order is higher. Now this is how the transitions is going to occur, electronic transition is going to occur, and this is the diagram which represent the electronic transitions, various electronic transitions which occurs during the absorption process. Now let us understand the basic principles of spectroscopy. Now this is based on basic principle of UV visible spectroscopy is basically based on Beer-Lambert's law. Now what is that Beer-Lambert's law? Absorbance A is directly proportional to concentration C of absorbing substance and path length, that is L, of the light through the sample. So this is the law. Law says that absorbance is directly proportional to concentration. So it is basically A is directly proportional to concentration, and they are saying it is also directly proportional to the path length, which is denoted by L. Now if you remove the proportionality sign, there will be some constant, and then constant is represented by epsilon. Epsilon into C into L. Okay. So this is how the Beer-Lambert's law was mentioned, and this is the formula. Okay, so let us see. Now if you write it in terms, you can see here the radiations or the ray which is incident, it is, if you represent by I0, incident light, and it is going through the sample, this is the cuvette. Okay, in that cuvette you can see the colored sample is taken, and there is the light which is getting transmitted. So on simple basic principle, the UV spectroscopy, it is running. So here I0 and IT, I0 is nothing but incident light, and IT is nothing but transmitted light. Okay, so A absorbance is equal to log to the base 10 logarithm of I0 upon IT. So absorbance is equal to what? Log of I0 upon IT, and which is nothing but epsilon C into L. So this law is the fundamental of UV visible spectroscopy. It can be used to determine the unknown concentration by measuring the light absorption. So if you try to find out the concentration of this given sample, this is the given compound, okay, chemical compound, and if you want to find the concentration, then you can use Beer-Lambert's law. Okay, so this is how, on the simple principle, basic principle, the UV visible spectroscopy we can use. Now the next is instrumentation of UV visible spectroscopy. The ultraviolet light is in the range of 200 to 400 nanometer, and it can be obtained using the light source, that is the light source which you are going to use, you can use is deuterium lamp for UV region and tungsten lamp for visible region. and you know that these are the two lamps which can use to have the source of light in the spectroscopy. Then there is a monochromator which will select the specific wavelength. Okay, so there is a chromator, monochromator. Monochromator means a single chromatic light waves can be selected. Then sample holder or cuvette, the usually quartz are used. Okay, glass are not used in this because glass can absorb UV radiations, so glass are not used here, but quartz are used. And the prism as well as the cell is made up of quartz. Then UV detector is there, measures the transmitted light intensity. So UV detector is used to measure the transmitted light, that is IT. And the solvent generally used in the UV visible spectroscopy is water or 95% alcohol or hexane. Then similarly UV visible spectroscopy works well for liquids and solutions. Okay, so you will require liquids or solutions for which UV visible spectroscopy can work well. Then output, basically you will get such type of a graph as output, that is absorbance versus. On y-axis you can have absorbance and on x-axis you can have wavelength. Okay, and if you try to plot the graph, it will be in this curve, and the highest point of this graph is indicates lambda max. Okay, it will indicate a lambda max. So here this is how the UV visible spectroscopy works. Now what are the applications of UV visible spectroscopy? So UV visible spectroscopy is used to determine the concentration of the solution. Okay, for example transition metal ions and organic compounds. Then study the reaction kinetics, that is kinetic reactions we can study using UV visual spectroscopy. Determining lambda max, so wavelength of maximum absorbance we can find out. Similarly we can also use it for qualitative analysis of conjugated system and functional group. So UV visible spectroscopy, actually we can detect for conjugated system and functional group, because these are the groups which are responsible for the absorption of light, UV light. Then it is also used in biochemistry for estimating the proteins, okay, and nucleic acid. So you can find that proteins, whatever is the functional group, and nucleic acid, they absorb the radiations of 280 nanometers and 260 nanometers. And that's the reason why proteins and nucleic acids can be determined or estimated using UV visible spectroscopy. So in short, UV visible spectroscopy is a simple, fast and powerful technique for studying electronic transitions in molecules and for qualitative determination of the substances. So I think this you understood simple principle of UV visible spectroscopy, its application. So hope so you understood the UV visible basic principle, okay, how the transition takes place and in what region the radiations are being absorbed by the electrons. That's all for today's session. Thank you for watching ChemONotes. Stay tuned with ChemONotes and watch all other videos which are been uploaded. Already I have uploaded 39 videos, so you can go through each one and do comment if you want any other topic which I should upload. So do comment below and subscribe, share and like the channel. Thank you for watching. Happy learning. Bye.